In this video, we're going to talk about pulse width modulation. Now, in previous videos, we used these analog ports down here, and the way it would work is that the ports would be able to sense a voltage, and when you executed the statement analog read, it would return a value proportional to that voltage. Now, the opposite of that would be is if you could enter a number in a statement and the board, the Arduino, would return a voltage proportional to that number. Unfortunately, the Arduino does not have that capability, although some microcontrollers do. Instead, it has something that's called pulse width modulation. Now, there's a little code here on the board. It says digital PWM. That's pulse width modulation. And there's a little squiggle next to it. And the ports that have that little squiggle are capable of pulse width modulation. Okay, now I'm going to explain exactly what that is in a minute, but I just want to show you the circuit that I have here first. All it is a 330 ohm resistor, just like you have in your kits, and an LED, and this side of the LED is connected to one of those pulse width modulation ports, and the other end of the resistor is connected to the ground. Now, this device up here is an oscilloscope, and an oscilloscope essentially shows a picture of the signal that is applied to the circuit. So we have the one terminal of the oscilloscope on this end of the resistor and the other terminal of the oscilloscope on this end of the anode of the LED. All right, now the code. Okay, now to implement pulse width modulation, you use this statement analog write, followed by the port number, and then a number anywhere from 0 to 255. Now let's take it halfway. Let's put, whoops, got to stop it before I can change that. Let's make this 123. Okay. Now 123 is clearly half of 255. So if we start simulation, we can see a picture of the signal. So basically what's happening is it's applying 5 volts half the time at that circuit. So you can see up here, this would be 5 volts, this would be 0 volts. This would be 5 volts, this would be 0 volts. What's the effect on the LED? Well, the effect on the LED is that basically it's flashing on and off, but it's happening very, very quickly. And so what does it look like to the naked eye? Well, it just looks like the LED is at half intensity. All right, let's try a different value here. Let's try to make this, let's make this 23 instead of 123. Okay, so now you can see that it's high only a short period of time and it's low most of the time. What does the LED look like? It looks like it's pretty dim because essentially it's off most of the time. All right, let's just try one more example. Let's try it at 230. That's almost maximum value. Okay, so you can see that it's high most of the time, and just this short interval here where it's low, the LED is lighting almost at full intensity. And of course, we could put 255 in there, in which case, why don't we just do it? We put 255. Then we're going to get 5 volts straight across. You got to wait for this thing to, there we go. So now we just get a solid 5 volts. This would be just like applying a direct 5 volts to the circuit.